Welcome to this Fundamentals Lesson Plan series on roofs, layout, design, and editing. In this video, we'll take a look at creating a gable roof using the roof by footprint method. This is video 2 of 9. My name is John Harridge, and I will be your host for today's lesson. Let's look at the learning objectives for video 2. At the end of this lesson, you will be able to create a roof sketch using roof by footprint method. Then applying slope property values to roof sketches individually, setting the specific slope values to get the right pitch, and then converting the roof sketch to a 3D roof element. With that, let's get started. Let me begin this exercise by showing you an instructor preview of the goal of this exercise. Again, the goal is to create a gable roof over the garage for the residential data set that we started the roof creation series with. With that, let's close out the file and we'll begin the hands-on exercise. Let's begin this exercise by opening up an existing exercise file to begin from. Go ahead and click Open, and then browse out to your tutorial directory and open up the Roofs 02 exercise file. So we begin in a 3D view, and again, the goal is to create a gable roof over the garage space. So to locate the roof tools, it's again in the Build panel of the Architecture tab, and we click on the pull-down menu for roofs, and this time we're going to use roofs by footprint. Let's go ahead and specify the level for the roof as garage roof. That's already pre-specified. Click Yes to continue. And now we can actually start modeling the roof line work. So before we begin, it'd be best to do this in an orthogonal view. So left click on the top label in the view cube so that we can do this in a plan orientation within a 3D view, and then zoom into the garage area so you can get up close. The sketching tools for the roof footprint are located in the draw area. We're going to use the boundary line tool to establish a closed sketch. And we might as well go ahead and leverage the walls that are already there. So I'm going to use the pick wall technique since it already establishes the footprint that we need. We're just going to associate the sketches with that. Before we do that, let's go ahead and set the overhang value to a value of 2 feet. So enter in 2 feet and hit the tab key to accept that value. Notice that there's also a define slope property in the options bar that could also be specified. Just letting you know that you can unmark that. In this case, we're going to leave it marked. Go ahead and place your cursor on the exterior face of the wall, and you saw that dashed green line as a preview. Go ahead and left click to place your first sketch. And in the Properties palette under Dimensions, you'll see what the slope value is. Move your cursor over to the right wall. Go ahead and place another sketch instance over there. And then on the Options bar, unmark Define Slope to create the end gable sketch line work at the 2 remaining wall boundaries. All right, so just zooming out. I just want to confirm that we actually have a closed sketch boundary. I'll hit the Modify tool to drop the sketching command, and then hovering on the sketch line work, I'll left click to put them in a selection set. All right. Next, we want to change the roof pitch of the sketches that actually create the gable. So if you select the sketch line that has the pitch glyph next to it, you can actually override the default value and just type in a new value. So let's go ahead and type in 6 and 12. You can do that either on screen or by selecting the sketch. You can also do this through the properties palette and actually specify the slope there. So it's really a preference issue as to which location you wish to specify that. Okay, just confirming that both slopes are set to the same value of 6 and 12, so it's an equal gable and not a salt box, if you will. It is a sketch environment, so we need to close out the sketch by selecting Finish Edit Mode. And then the question that's prompted to you is, do you want the walls to project to the underneath side of the roof envelope? And we want to choose Yes. All right, using the View Cube to navigate, let's go ahead and go back to the Home view. And let's just confirm that we have a clean envelope between the walls and the roof is the correct shape. It appears to be so. Let's open up the garage roof floor plan and let me just show you something else. Why was it important to use pick walls as a sketching technique? Now let me do this again. I'll use the 3D view instead, and I'll rotate this back to a plan view, and I'll turn on wireframe as the display mode. What we did when we used the pick wall technique is we created a parametric relationship between the roof footprint sketch and that wall, so that if I select and drag the wall, notice that the roof boundary follows. So that was the parametric relationship that we established when we used the pick wall technique. So let me hit undo just to confirm that relationship. It doesn't matter which wall we choose because we use the same pick wall technique. It also works with the end gable wall condition as well. Clicking OK to undo that. And let me reset the visual style back to hidden line. And let's take a look at this from the south elevation view. We chose the roof to be hosted on the garage level, so if we were to change the height of the garage level, the roofs and the walls hopefully will follow and not break, and it did in this case. So I just changed the level by 1 foot, and both the roof and the walls moved to heel to follow that new value. I'll hit undo to reset that, and let's go back to the 3D view and go back into the home view and maybe orbit the model just so we can see this again from this perspective. This concludes this exercise. Go ahead and save the file as Roofs 02 exercise finished. Click save after you give it a name. Again, this is the conclusion of this exercise. Let's take a look at next steps. Let's review the learning objectives for video 2. In this lesson, you were able to create a roof sketch by using roof by footprint method, then applying slope properties to individual roof sketch lines. Next, we were able to set specific slope values through the properties palette. And then last, we were able to convert the roof sketch to a 3D roof element. With that, let's take a look at available Autodesk resources available to you. I would like to make you aware of 2 Autodesk resources. The first resource is the Autodesk Education Community, where you can access free software for both students and educators for titles like Autodesk Revit featured in this series. The website address is www.students.autodesk.com. Registration is required to access the free software using either your personal email address or your school-issued email address. The second resource is the Autodesk Digital STEAM Workshop. It's hands-on, project-based learning across multiple industries such as architecture, engineering, and entertainment. The website address is www.digitalsteam.autodesk.com. Registration is required to download the free learning resources using your Autodesk ID created from the Autodesk education community. You will find the Fundamentals of Architecture series under the Subject pull-down menu, Architecture link. Assets include step-by-step instructions, datasets, and videos. This concludes this exercise. Thank you very much for watching.